In our last lecture, we have discussed about the structural analysis based on the loading condition. It is classified into two cases. One is static analysis, another one is a dynamic analysis. And today we are going to discuss about the difference between the linear and non-linear analysis. So again, this linear and non-linear analysis can be static or dynamic. It depends upon the loading condition. So in the linear elastic analysis, basic assumption is that a relationship between the input and output should be linear. That is that a relation between the loading input is loading and our output, one of the output is displacement. If you see, the relationship should be always linear. That slope line can be anything, but the slope should be always constant from start to end of the analysis. So the another assumption is like in case of flexural element, if the deflection del because of this load P, applied load P is PLQ by 48 EA. Here this EA is called flexural stiffness. This E means Young's modulus of the material and I is the second moment of inertia. So this EA is indirectly proportional to the deflection and directly proportional to the applied load and the span of the element. So in case of torsional load, the torsional deformation is called the theta. The theta also it's depends upon the torsional stiffness or torsional rigidity GJ. This GJ is high, that torsional stiffness is I for this particular element, the deformation will be less. Same way, the length is more or the force or torque is more, the deformation will be more. So in linear analysis, the rigidity and the rigidity means that it's all that polar moment of inertia or the second moment of inertia in case of the flexure beam. So these all depends upon the cross section. So this cross section is always constant. So the rigidity and corresponding stiffness value of the material must be remain constant throughout the analysis. That is one another important assumption in the linear elastic analysis. So in case of non-linear analysis, once the load is exceeding the yield point, this will get cracked and this property will keep on changing. That geometry, I mean that matrix, stiffness matrix will be keep on changing throughout the analysis. In case of linear analysis, that is not the case. It will be remains constant. The another assumption is all the material used in the analysis should follow the Hooke's law of elasticity. Hooke's law, what it states is like the deformation is directly proportional to the applied load or the stress induced in the element is directly proportional to the strain. If you see in this diagram, this is the original shape position of the spring. This is the helical spring. So when we apply a load W, it extend distance x. Suppose if we apply load 2W, the deformation also will be 2x. So which is state that it is directly proportional. This it's maintain its linear relationship between the applied load and the deformation. So that's what that all the material used in the elastic analysis should follow the Hooke's law of elasticity. So another assumption is the material should be in elastic. Elastic means, say example, this is original position. When we apply some loading, let's say F, it uh, the length is increased to x or the deformation is x. When the load become 2F, again this deformation also 2x. When the load is removed, it's not having any residual deformation. It's again going to complete its original shape. So that is perfect elastic material. Most of the elastic material show the linear behavior like this, but there are some exceptional. For example, the rubber is an example for the elastic material. which will follow the non-linear behavior. So the another important principle is the principle of superposition is valid in the linear elastic analysis. What is principle of superposition? The analysis result does not depend upon the load step or load history or rate of loading. If you understand easily, let's say example, there is a cantilever beam which is subject to 100 Newton at that free cantilever end, which is going to create a 5 mm deflection. If the same beam is going to create a 2 mm deflection when load is applied, maybe L by 2 span. So when this both the load is applied together, the final deflection should be equal to the sum of the first two case. So what does it mean is like the load step, whether the which in this which load is applied first or which is applied later, or whether these loads are applied uh, independently or simultaneously, it doesn't matter. So the final result will be always same. What we, for example, we are studying the deformation, but in case of anything, bending moment, shear, stresses, anything, if you compare, it will match. So even in our any, if you take any commercial software also, if you do analysis for like three primary load case, if you consider in your analysis a dead load, live load, wind load. Suppose if you want to study the combined effect of these things, suppose 1.5 times dead load plus 1.5 times live load, no need to analyze by applying all these load put together and applying 1.5 times factor and all. So if you have result for dead load and live load, you can take that result and you can multiply with the constant 1.5 and you just to add it and you will get the final effect. So that is how even commercial software, all the commercial softwares are working. So this principle of superposition is valid in a linear elastic analysis. This is not valid in the non-linear analysis. So in summary, the linear and non-linear analysis applied on a structure depends upon the three important parameter. One is the material, whether it is elastic or plastic. Another one is the displacement. After analysis, the displacement, whether it is going to be within the limit like a small deformation or very large deformation. And another one is the boundary condition, whether the boundary condition is constant throughout the analysis or it's keep on changing. So it depends upon the applied loading condition. Based on this, so we can classify whether it is a linear analysis or non-linear analysis. Based on the material, in the linear analysis, always use the elastic material, and the deformation, the deformation is very small, at the time we have to use linear analysis. In case of non-linear analysis, consider the large displacement and elastoplastic material. So if you see in the stress strain curve relationship as well, the second characteristic is stress-strain relationship. The linear analysis obeys the Hooke's law, and the stresses are proportional to the strain till yield point. Nonlinear analysis does not obey the Hooke's law, and stresses are not proportional to the strain even in the elastic limit. And the another characteristic is principle of superposition, which is allowed in linear analysis and not allowed in the nonlinear analysis. And another characteristic is reversibility. So analysis does not depends upon the load step or load history. In nonlinear analysis, the analysis depends upon the load steps or load history. So the stiffness matrix remains constant during the analysis in the linear analysis, and but this phenomena does not apply to the nonlinear analysis because that stiffness matrix will be keep on changing in a nonlinear analysis or depends upon the type of nonlinear analysis. And the deformation will be reversible in linear analysis and irreversible in the nonlinear analysis. So in the next lecture we will discuss about there are different type of nonlinear analysis, and maybe that is classified into material nonlinearity. So it can be a elastic or plastic. Same with large displacement of the structure means, so we have to go for the geometric nonlinearity. And boundary condition means throughout the analysis, the boundaries are keep on changing. In case of a compression spring or tension only spring, to represent the uh, soil stiffness under the box culvert, something like that. That we will discuss in detail in the next lecture.